This is not water damage. This window was built to be filled with water, on purpose. A standard window does almost nothing to stop solar heat from cooking a room. This one absorbs that heat before it ever gets inside. In real field tests, it's cut heating and cooling energy used by up to 70%. No compressor, no refrigerant. It's called water-filled glass. And by the end of this video, you'll understand exactly how it works, where it already exists, and why it isn't standard in American homes yet. The technology comes out of Loughborough University in the UK, developed by architect Matyas Gutai. Gutai had spent years working in Japan, including in a research lab focused on architecture shaped around natural materials. He kept coming back to one question. What if water, not glass or gas, was the real insulator? Most modern windows trap a thin layer of gas, usually argon, between two panes to slow down heat transfer. Gutai's design replaces that gas with clear, circulating water instead. In 2020, that idea became a company, Water-Filled Glass Ltd. This is secret number one, the physics of why water beats air. Water can absorb and hold far more heat energy than trapped air before its own temperature rises. That property is called thermal mass, and it's why water has been used to store and move heat for centuries, long before it was ever used in a window. In this design, the water doesn't just sit still, it circulates through a small system connected to a heat exchanger. That means the heat the window absorbs doesn't just disappear. It can be reused to warm water elsewhere in the building, for example. According to the developers, moving heat through water this way is up to 10 times more efficient than heating or cooling air directly. That matters most in buildings with a lot of glass, where solar heat gain is usually the enemy, not the ally. Normally, more glass means more heat pouring in, and a bigger air conditioning bill to fight it. With water-filled glass, that same wall of windows becomes part of the cooling system instead of working against it. That's secret number one. Now here's where it gets more interesting, because this window doesn't just block heat, it knows which season it is. Secret number two, the same window works in reverse depending on the season. In summer mode, the water layer intercepts solar heat before it ever reaches the room and carries it away through the circulation system. The room stays cooler, without a single watt spent running a compressor. In winter mode, that same water layer does the opposite job. It holds on to the heat trying to escape the building, instead of letting it leak out through the glass. Glass is normally one of the weakest points in a home's insulation. This turns it into one of the strongest. One window, two completely opposite jobs depending on the time of year. When the company unveiled the design publicly at a major architecture trade fair in Munich, they placed tiny gold flakes inside the water, just so people could actually see it moving. The frame itself is aluminum, chosen because it can be recycled indefinitely, keeping the whole system sustainable long after installation. That's secret number two. But a diagram and a lab test are one thing. Does this actually exist anywhere, right now in a real building? Secret number three, it already does, in more than one country. The first full prototype, called Waterhouse 1.0, was built in Hungary. It became the proof of concept, a small building that could regulate its own temperature almost entirely through its windows. The second version, Waterhouse 2.0, was built at Loughborough University in Taiwan, a hot, humid climate about as far from Hungary's as you can get. Same technology, two opposite climates, both used as real-world testing ground rather than just computer simulation. The company is now completing its first commercial-scale projects, including an industrial building in Hungary. And an apartment complex here in the United States, currently under construction, the first American building expected to use this system. This isn't a renders-only concept. It's a construction site right now. And the company says it's not just for new buildings. It's designed to be retrofitted behind existing glass, especially in smaller spaces that heat up or cool down fast. That's secret number three. But this raises an obvious question. Is water-filled glass the only version of this idea being tested? It isn't. Researchers in China have tested a related approach, filling window layers with a copper sulfate solution instead of plain water. That blue solution filters out near-infrared heat rays while still letting visible light through, so the room stays bright without the extra heat load. In field testing during summer in Luoyang, China, researchers compared rooms with this liquid layer against ordinary windows, measuring real indoor lighting and temperature differences, not just simulations. Different research teams, different countries working independently. But they're circling the same core discovery. A liquid layer inside a window outperforms trapped air or gas. So if the physics checks out and the buildings already exist, the next question is the one that actually matters to you. Why isn't this in the window at the front of your house right now? Part of the answer is simple: cost. A circulating water system with a heat exchanger is more expensive to install than a sealed gas gap that never needs maintenance. Standard windows are fast to install, cheap to source, and familiar to every contractor in the country. That familiarity has value in construction, even when it isn't the best performing option. Building codes and energy standards in most US states were written around a small set of familiar window technologies. A circulating liquid system doesn't fit neatly into that paperwork yet. That doesn't mean it's banned, it means it's unfamiliar, and unfamiliar things move slower through approval, financing, and insurance. And there's a quieter reason. The heating and cooling industry sells equipment, service contracts, and replacement parts. A window that does part of that job for free isn't a product anyone in that industry is incentivized to advertise. Nobody is hiding this technology. It's published research, patented, and publicly documented. It's just competing against an entire industry that has no reason to bring it up. The honest way to put it, this isn't a conspiracy. It's a shape and a system competing against a much bigger, much older system, and losing on familiarity, not on performance. Up to 70% less energy used on heating and cooling. Already built, tested, and standing in 3 countries. Just not standard yet. The next time you feel a window radiating heat into a room on a hot afternoon, remember, that heat didn't have to get in at all. Somewhere in the US right now, a building is going up that won't have that problem. The question is how long it takes for that to become normal instead of an experiment. If you want to know the moment this technology reaches ordinary homes, that's exactly the kind of story this channel follows. Would you install a window like this in your own home, or does it still feel too strange to trust? Tell me in the comments. I read everyone.